45.65 divided by 79.5. How much are you getting?
So it can I have a minute? A minute.
I will. You just have to use your calculator, most.
Yes, I know how to divide, but
What is the problem?
so you said the first one that yes. No, I can't find my calculator, and it was in my bag.
Oh, okay. Nungo, how much are you getting?
Um, 0.574 mole.
Okay, 0.574 moles. Okay, Makati from here. Step number 2.
Right, we found the number of moles.
We have found the number of moles. Now we are going to step number 3. Use stoichiometric ratios to calculate the number of moles of other reactants and products. So to do so, you have to go back to your balanced equation. I'm going to write it down properly. Your balanced equation was 2CuO plus carbon, giving you 2 copper plus carbon dioxide. This is what we had. Now, according to the law of fixed proportion or the law of definite proportion, it says that each and every time copper oxide reacts with carbon, they will react in this manner all the time. They will react in these ratios. 2 moles of carbon oxide will always react with 1 mole of carbon to give you 2 moles of carbon copper plus 1 mole of carbon dioxide. That is the law of fixed proportion.
So can you please repeat that?
The law of fixed proportion states that each and every time 2 moles of copper oxide will react with 1 mole of carbon dioxide to give you 2 moles of copper plus 1 mole of carbon dioxide. That is the law of definite proportion or the law of fixed proportion. Makadze, are you following?
Yes, sir.
Okay. So given that you know the number of moles of copper oxide, how are you gonna calculate the number of moles of carbon? Because that's what we are looking for. Makadze.
So I think we have to write the ratios down.
Okay, let's write the ratios down. Okay, let's start.
So I think we're gonna say CuO is to C.
Is to C. Perfect.
And then we're gonna say 2 is to 1.
And then
okay, yeah, I'm not sure. So I think.
But you have calculated the number of moles. What does that number represent, Kanin?
It represents CuO. So I think we're gonna write under CuO we are gonna write 0.574.
Exactly. Is to what?
Is to X.
Yeah, that's perfect.
Wow. So yes, you see I'm getting there. Say yes.
Yes. So from here
we are gonna cross multiply.
Okay. So 2x is equals to 1 times 0.574, which is 0.574. So X will be, if you divide both sides by 2, do you agree, Makazi, with that?
Yes, sir.
How much are you getting? 0.2?
0.287.
287. And the units?
Isn't it moles?
Moles. So do you agree that this is N for carbon? This is the number of moles for carbon. You agree?
Yes.
Okay. So from here, what do you do? We are looking for the mass of carbon. What do you do from now?
From your side, I don't know.
Okay, in stoichiometry, you're gonna be dealing with, okay, Nungo, what equation were you gonna use?
So after
After
when I
calculating the number of moles of carbon.
N equals to big letter small letter M over big letter M.
That's what you're gonna be using throughout, Makadzi. This equation must always be in your mind.
Okay,
So from there, it's gonna be 0.287 is equals to M over Makadzi. What will be the molar mass of carbon? Molar mass of carbon
So do we substitute the big letter M with
the molar mass?
the one that we calculated?
Yes. Which is the molar mass of carbon, because this is the number of moles for carbon.
Sorry, I'm not. Is it gonna be 0.574?
The molar mass. What is the molar mass?
I'm not sure then.
Okay. Okay. What is the molar mass of oxygen?
It's 16.
Okay. What is the molar mass of carbon?
It's 12.
Then why were you not sure?
Oh, because so I didn't know what to do.
The molar mass are acquired from the periodic table always. So if you cross multiply, you are going to have 12 times 0.287. 12 times 0.287 is how much? Do you have a calculator now, Makats?
Yes, I do.
Okay, how much did you get?
3.444.
3.444 grams. That is correct. We did solve for the mass of
Sir, but
yeah.
I don't understand here
Which
at
part?
the last step where we had to substitute with 12.
Oh, okay, now I see. Okay, let me re-explain it. The law of fixed proportion says that each and every time copper oxide reacts with carbon, it will react in a ratio of 2:1. That's the law of fixed proportion. You agree with that?
Yes, sir.
Okay, so we are very lucky that we have calculated the number of moles, which turned out to be the number of moles of copper oxide turned out to be 0.574. Okay, and then when we calculated the number of moles of carbon, it turned out to be 0. 287. Makaz, I want you to take your calculator. Ne?
Yes. Yes. Sir.
And divide 0.574 and say 0.574 divided by 0.287.
Divided by how much, say?
Divided by 0.287.
It's 2.
It is 2. So do you
Yes.
see that we did preserve the ratio?
Yes. Sir.
Okay, let me ask you, how many moles of copper is going to be produced? In this case, you don't need to do any calculation. You can, if you want, but it's gonna be a quick one. How many moles of copper are we gonna produce?
So is it 12?
Moles, not molar mass. Moles.
Oh,
There's a different.
so I'm not sure.
Moles is N. This is a mole, and this is also a mole. You're not sure. Nungu, how much or how many moles are we gonna produce for copper? If we are considering the law of definite proportion, how many moles of copper are we gonna produce? Nungu.
So could you please repeat your question?
If you are using the law of fixed proportion or the law of definite proportion, without
Yes.
using any calculator, how many moles are we gonna produce for copper?
For copper, we're gonna have for copper we will have 0.574 moles.
0.574 moles. And then for carbon?
Then for carbon, we're gonna have 0.287 moles.
That's correct. So Makazi, what I want you to observe is that you can see that the ratio between the mole of copper oxide and copper, it is 1:1. Do you see that?
So the ratio of what?
The ratio of copper oxide and copper produced, the moles, it's actually 1:1. Do you see that from the balanced equation?
Oh, yes.
So if it is 1:1, it means if the number of moles of copper oxide is 0.574, you are going to produce also 0.574 moles of copper. Or you can do this, it's fine. Copper oxide is to copper. Okay, to avoid confusion, you have 1:1, and then you have 0.574 is to x. If you cross multiply, 1 times x will give you x, and 1 times 0.574 will give you 0.574. So you can see that x is on the side of copper. If you're calculating the number of moles for copper produced, it's going to be 0.574. Makazi, do you follow that?
Yes, I get it a little bit. Yeah.
A little bit, okay. Now, do you understand why we used 12? Makazi,
Say?
do you now understand why we used 12?
Say?
Do you understand why we use 12?
Oh, yes, say.
We are
But-
using 12 because we were considering carbon, because that's what the question was asking, the mass of carbon. Okay. I think we are in the same page. Let us move on to the next question. Okay. 2.3.1, the volume of carbon dioxide produced at STP. Okay, markers. What will be the volume of carbon dioxide produced at STP? How are you going to go about it? Okay. Okay, give me a few seconds. I just want to do this. Okay. Let me insert fewer pages. Okay, perfect. Markaz, so how were you gonna go about this question?
I think I was gonna use that formula of n equals to v over m over vm.
Okay, I'm trying to go back. Okay, where was I? Okay. Okay, perfect. So in order to calculate the volume of what is it that was produced? The volume of hey, what is it? Okay, the volume of carbon dioxide. You said you were going to use which equation?
N equals to v over vm. So I'm not sure though.
Don't doubt yourself. Nungo, do you agree with it?
Yes, sir.
Yeah, that is perfect. Or you can say V at STP, it's fine. Okay. And then what are you gonna use? What were you gonna use from here, Markaz?
So right, the other v on top is actually the number of moles T. So So I think that we were gonna use the number of moles that we the first one that we calculated.
Why are you using the first one?
There is
Nungo, do you agree with that?
Yes, sir.
Why are you using the first one? Because they said the volume of gas produced for carbon dioxide.
So what am I agree? So
Okay, Nungo, which is how much? The number of moles that you're gonna use is gonna be how much?
we're gonna use the number of moles that we found for carbon.
For
Carbon.
carbon or carbon dioxide?
We're gonna use the number of moles that we found for carbon, which is 0.287.
Why carbon? Because we said carbon dioxide gas.
Yes.
But you're saying carbon.
I am saying we're gonna use the same number of moles that we used for carbon.
Oh, because it's the same. Okay.
Yes.
This is the one. Okay. Makazi, the thing is, you can also recalculate it using ratios. You're gonna get the same. You're gonna get 0.287. Okay, for Makazi's sake, let us do it. It's fine. So the ratio of copper oxide is to CO2 produced, is actually 2:1. 2:1, sorry, yes. And then the number of moles of copper oxide that we have calculated was 0.574. And then in order to calculate the number of moles of carbon dioxide produced, we are going to put X. Then when we cross multiply, 2 times X will be 2X. 2X is equals to 1 times 0.574. It will be 0.574. So if you have 0.574, if you divide by 2, you are going to have X is equals to 0.287. That is the number of moles of carbon dioxide. Okay. Now from here, what we're going to do is we're going to use the same number of moles of carbon dioxide we have calculated, which is 0.287 is equals to, Makads, is equals to what?
Sir,
Yes.
can you please repeat your question?
Okay, I have substituted the number of moles of carbon dioxide. What should I substitute on V and VSTP?
Sir, I don't. The V, I know that it's number of moles.
Nungo, do you agree that V is the number of moles?
Oh,
No,
no,
sir.
no. The V is the volume of gas.
Okay, so do we have the volume of gas?
So wasn't it given at the question?
No, that's what we are trying to calculate. They said calculate the volume of gas produced. Okay.
So I think we are gonna leave the V and then the VM, the molar gas
Yes. It's how
volume.
much?
So is it the one that's always constant?
Yes.
So it's 22.4.
22.4. Okay, so from here we will cross multiply. 1 times V will give us V. And 0.287 times 22.4 will give us, Makazi, use your calculator. Let's see what we're going to get.
It gave me 6.4288.
Okay. 6.429. Let me take it to there. And what is the units, Makazi? What is the units?
Isn't it dm cubed?
Yes, it is dm cubed. It is dm cubed. Okay, that's perfect. Those are the units, dm cubed. Okay, let's see what the next question says. dm cubed. Okay, let's go to the next question. 2.3.2. Okay. The mass of carbon that reacted with copper oxide. Nungu, how do we go about this one?
I've already calculated it.
The number of moles.
No,
the mass.
yes.
Oh yes, we have already done so. Yeah, you're right. Okay. What is the number of moles of copper that will be produced? No.
It will be 0.574 moles.
Okay. Okay, that's fine. That's easy work. Okay, that's very easy. You just use ratios. Makazi, you just use ratios from the law of fixed proportion. Let's see. Hey, who is trying to enter? Oh, Kumisa. Oh, Kumisa did made it. Okay. Okay, that's perfect. Rendani. Rendani? Rendani, are you there? Rendani? Okay. Rendani seems to... Okay, it's fine. Okay, Nungo. 2.3.3. The number of moles of... Oh, this one we have already calculated. The number of moles of copper that will be produced. So how many number of moles of copper that will be produced?
Oh, I said 0.7 or 0.574 moles.
0.574 moles. So in order to calculate it, we are going to have the number of moles of CuO is 2. The number of moles of copper, it is 2:2, which is actually 1:1. And we have calculated the number of moles of CuO, because the first step of dealing with stoichiometric equations is to calculate the number of moles using the given, which we have already calculated the given. And we found out that the number of moles of CuO is 0.574 is to X. If you cross multiply, you will have X is equals to 0.574, and that is correct. Now, if 4 decimeter cube of carbon dioxide was produced, what is the percentage yield of the reaction? Rendani, are you there? Rendani, are you there? Okay. Kumisa, how are you gonna go about this one? Kumisa? 2.3.4. Kumisa? Okay, Makazi, do you want to give it a try? Makazi? You can give it a try. Makadzi. Makadzi, do you want to give it a try? Makadzi, can you hear me? Nongo, can you hear me?
Yes, sir.
Oh, okay. Makadzi, can you hear me? Makadzi? Hey. Rendani, can you hear me?
Yes, sir.
Okay. So how were you going to
Sir,
attempt?
my screen was black. I couldn't open the microphone.
Okay, but is it fine now?
Yes, sir.
Okay. Rendani, can you give it a try? 2.3.4.
Okay.
If 4 decimeter cube of carbon dioxide was produced, what is the percentage yield of this reaction? Percentage yield of the reaction. Okay, yes.
I'm thinking that we would first get the grams,
Okay,
the mass of the CO2 that was produced.
okay, which is how much? So how are you gonna go about it?
We can use the formula. Wait. Oh yes, we can use the formula. Oh, I'm not even sure.
Okay.
N is equals to V over Vm, and then we can first get the number of moles, and then we can substitute it into the formula. Yeah. Yes.
Okay, no problem. I'm gonna do that. So you are saying we're gonna use the formula. So this is 2.3.4. Fine.
Okay.
N equals V over V STP. Are you using this one?
Yes.
Okay, and then the number of moles.
I'm not sure, but then I know we're given that V is, what is it again? 20.
The V, 4. I talking
Yes.
about the 4. Okay,
Yes.
I'm gonna put 4. It's fine. Or you are trying to calculate the number of moles. Okay, no problem.
Yes.
4 divided by V at STP. This is a given.
22,4.
So what are you gonna get?
0,178. 179.
0.179. Okay, perfect. And then from here,
And then from there, we could calculate the molar mass. I mean the mass using the formula N is equals to small letter m over capital letter M.
okay.
Yes.
And
It's
then
carbon
what are you gonna?
dioxide, no?
Mm-hmm.
Oh, and then we can say 0,179.
0.179 is equals to M
And
over
wait.
Not sure.
M over 44.
Oh, 44.
Yes.
Okay. So your M is gonna be 0,179 times 44, right?
Yes.
Which
Yes.
is how much?
Which is 7,876.
7,876 grams.
Yes,
Fine.
grams.
Okay.
Yes. And
Yeah.
then they're looking for the percentage yield.
Yes.
So then, wait, let me go get something that.
Yeah. But do you know the formula for calculating the percentage yield?
Yes.
Okay.
Isn't it actual? Wait,
Okay.
yes. Actual yield over a theoretical.
Yield percentage is given by actual divided by theoretical. That's perfect. Okay. So from here, what do we do?
From there, I'm stuck.
Okay. Nungu,
Sir?
what is your take?
Sir?
What is your take?
Okay, so what happens to me if so since we have our formula, we already know that carbon dioxide has the same number of moles as carbon. So maybe what if you take the number of moles as 0,287, then you use the formula N is equals to small letter m over big letter M. Then you substitute with your 0,287, then you multiply. What happens? Is it wrong?
Okay. For theoretic, right?
Yes.
Yes. Okay. What we have calculated there is the actual, which is 4 grams. I agree. Theoretic, we're gonna use the same formula, but we know the number of moles, which is 0,287 is equals to m over the number of the molar mass will be
It will be 44.
it will be 44, and the mass will be how much? It will
And
be
the
0,
mass, it will be
0,287 times 44. You agree?
yes,
Which is how much?
12,628
12,628.
grams.
Okay, grams. Okay, so from here,
I have a question. So,
no.
is the one that we calculated using the volume the actual mass?
Which one? This one? This one?
The above one, the
This
one that
one?
we calculated. Yes,
This
the
is
one that
actual.
we calculated.
Okay, let us go to the question and see what the question said. Okay, if we go to the question said, if 4 dm3 of CO2 was produced, isn't that the actual?
Yes, it is.
Okay, perfect.
Thank you.
Now, what do we do from there?
So we substitute, we write the formula. Actual mass produced divided by theoretical mass produced multiplied by 100.
Divided by theoretical mass multiplied by 100. Okay, so when we substitute, the actual turned out to be 7,876. 7,876 divided by 12,628 multiplied by 100. So if you use your calculator, how much are you going to get? No. How much are you getting?
62.37%.
You're getting how much? 62.
Yes, 37.
2,37.
37.
Okay. Did you get Marcus, did you get the same thing?
So I didn't do it, but then yeah.
Oh, but you agree.
Yes.
Oh, okay. I just want to try something.
So, did we
No.
not say 7,8? Did we not say 0, let me check. 4 over 2,4. Did we not say 0,178? But then we're saying 7,876.
On which one? 0,
Oh, I see it now. Sorry.
you see it now. So you are answered now.
Yes.
Okay. I just want to try something. Okay. We were given, we were told that, okay, I just want to see if this will work. If it doesn't work, it's fine. Actual volume divided by theoretical volume. Okay, the actual volume, we were told it is 4. You agree? And then the theoretical volume that we have calculated, it was 6,429. 6,429. $6,429. If you use your calculator, Makazi, how much are you getting?
So I got 0,62. It's a very long number. 0,622.
Okay, let me multiply by 100. Sorry, I forgot to. How much are you getting?
62,22%. 62,22%.
Okay, fine. Okay, let me try using the calculated, the actual moles divided by the theoretical moles. Nungo, you remember we have calculated, okay, moles, actual divided by theoretic moles times 100. I just want to experiment. So if you do that, what was the actual moles? No, let me go up a bit. The actual moles that you have calculated.
It was 0,179.
It was 0,179. Perfect. 0,179 divided by the theoretic moles of carbon dioxide produced. It was
0,287.
Okay, times 100. How much are you getting? I just want to see something.
It's 62,37.
62,37.
Yes.
Okay, that's perfect. 60, is it? 62,37. Do you notice? It's in percentage. Do you notice the similarity between all the three answers?
Yes, sir.
Yes, sir.
Okay. Do you realize that instead of you guys doing all the mass calculation, what, moles, this and that, do you realize that you could have as well used the volume? Do you realize that?
Yes.
So if you are in the exam, given that you are time restrained, you must know these three formulas. You must understand the fact that either way you can use the actual moles divided by the theoretical moles produced, or you can use the actual volume divided by the theoretical volume, or you can use the actual mass divided by the theoretical mass. The reason why I'm doing this is because I don't want you guys to be stuck on a question when you can have other short and very quick alternatives. Are we all together?
Yes, sir.
Yes.
Okay. So that's perfect. Let's see what the last question say. And then from there, I'm gonna do say maybe 20 minutes of physics. Then we will be done with the lesson. Let's see what the last question says. It's very easy. Markers, it says write down the formula of anhydrous copper 2 sulfate and calculate its molar mass. Copper 2 sulfate. So I'm gonna do this one with you guys. It's fine because I know it will be a bit harder for some of you. Copper sulfate. So the two inside the brackets. That's actually 2.4. It's fine. So copper 2 sulfate. Okay, so the 2 inside the brackets, it represents the number of electrons that are going to be lost for copper. And the sulfate, a sulfate is a polyatomic ion. You remember on the last lesson we did, we have talked about polyatomic ions. And the sulfate turns out to, this is sulfate, SO4. It has a 2 minus charge. So if you have the two ions, when they combine, what are we gonna have, Makats?
Say, I'm
Yes.
not sure.
Okay. Rendani, are you there? Oh, Rendani is not with us anymore. Kumisa, if you combine these two ions, what are you gonna have? Okay, Nungo.
You have CuSO4.
You will have CuSO4. So what happens is you drop that 2, you drop it to here, and you drop that 2, you drop it to here. So what you were gonna have, it was gonna be copper 2, and then sulfate 2. But then because there's a common factor, you were gonna have 2 into copper sulfate. And then you can just crush that 2, it's fine. We don't really need it. Okay, that's fine. Makazi, what is the molar mass of copper sulfate?
Say, for copper is 63.5.
63.5 plus
32.
sulfur is 82.
32.
Okay, 32. And then what else? Makazi?
Say,
Plus what?
I think you're gonna add oxygen plus
Mhm.
16.
Plus 16.
Yes.
Nungo, do you agree with that?
Oh no, say no.
Hmm.
You're gonna say 2 multiplied by 16, right?
Which 2?
So what do you mean, like
It is not 2, it is
oxygen
4.
is
No, oxygen has a 4. So if it has a 4, we will multiply with 4. If it was O2, I agree with you. We're going to multiply with 2.
so I didn't see the 4, seriously.
No problem. So if you multiply with 4, what are we going to have? Use your calculator. Let's see.
159.5.
Okay. 165.
No, sir. 159.5.
Okay. 105. Let me write it properly. Okay. 159.5. Makazi, what are the units?
Isn't it moles?
Nungo, do you agree with that?
Then it's not grams per mole.
It is grams per mole. Yes. Does anyone have any question? Any question?
No, sir.
Kumisa, do you have any question?
No, sir.
Okay. Okay, that's perfect. That is perfect. So now I want us to do a bit of physics. I want to do a bit of physics. Okay. We'll try to do it on this page. It's fine. Okay, I want to do a bit of physics. Okay. Last time we were doing vectors and scalars. Kumisa, what is a vector? Kumisa, what is a vector? Okay. Makazi, what is a vector?
It is a physical quantity with magnitude and direction.
That's correct. Magnitude and direction. Okay, Nungo, what is a scalar?
The scalar only has a magnitude but no direction.
Okay. A scalar only magnitude. Okay, and then last time I said we were going to start with the chapter or with the section of head and tail and parallelogram method of finding the resultants. So we have the head and tail. And the parallelogram method. Okay, fine. That's fine. Okay. Let's say we are given the following vectors. The first vector goes in that direction. And the second vector let me change the color to make it a bit different. Let's say if another vector goes in that direction horizontally. If they say find the resultant, first of all, a resultant is the sum of all vectors. The sum of all vectors. So before we start with that, let me give you another example. This is a complicated example. I'm not going to touch it now. I'm just putting it on board. No problems. Okay. Let's say, for instance, you have a vector going horizontally. And another one also going horizontally. In the opposite direction, if they are parallel. Okay. I should have used a different color here. No problems. Okay. I'm going to extend with a green. No problems. Okay. Let's say, for instance, if the vector we are dealing with, if this vector was 10 and this one was say 7, the resultant will be equals to, because we are dealing with vectors, vectors have magnitudes and direction. So before you start with vector questions, you need to choose the direction. In this case, I am going to choose right as positive. And upwards as positive. Unfortunately, we don't have, if I'm considering these two vectors, they are only in one direction, which is a horizontal direction. So the resultant in this case will be, the first vector is 10. It is going to be plus 10. The second vector, it's in the opposite direction of positive. Therefore, it is going to be a minus. It is going to be negative. So if it is negative, it's going to be negative 7. So the resultant will be positive 3. That is the resultant. Okay. This is example number 1. Okay, I'm going to give you another example. So say if you have 2 vectors. So like I said, vectors have direction. So the positive shows the direction is going to the right. So you can also say 3 to the right. This is a vector. A vector has a magnitude and a direction. The magnitude is 3. The direction is to the right. I'm going to give you another example. E.g. 2. Let's say if the first vector is 5. The second vector is minus 9. And the third vector is 2. Misa, what will be the resultant? So what will be the resultant?
Is it going to be 5 minus 9 plus 2?
It is going to be, let's see, 5 minus
9 plus 2.
9 plus 2, which is how much? Which is how much?
Negative 2.
Negative 2. So if it is negative 2, okay. Okay, so if it's negative 2, let me write the negative 2. Okay, perfect. Negative 2. So this will be 2. What is the direction, Kumisa? What will be the direction? Kumisa?
Is it left as negative?
Yes. Is it to the left or to the right?
Left.
To the left. Yes, that's correct. That is the resultant. It has magnitude and direction. That is a vector. Now, there's an example I've put when we started off with vectors, which is two vectors that are in different directions. And these two vectors will yield a resultant. All vectors must be summed up to give you the resultant. And what you must note is that in your syllabus, in the grade 10 syllabus and the grade 11 syllabus, you are going to be dealing with vectors in 2D. What it means is that you will be dealing with vectors that are in 2 dimensions. So the number 2 means that you will be dealing with 2 axes, the x and the y axis. So in your syllabus, you must be able to represent your vectors inside your Cartesian plane, which is in 2D. The 2 is for 2 dimension, x and y. That's 2D. Okay, that's fine. So in the example that I have given you, you have 2 vectors. The other one is going in that direction, and the other one is going in this direction. Vectors can preserve their direction and the size of their magnitude, meaning that I can actually take this arrow and put it here. As long as I preserve the size of that arrow, it is the same thing as what we had initially. So you are allowed to connect the vectors in whatever way you want to. You can even take this vector and come and put it there. which is what I'm going to do, because I have introduced a topic of head and tail. So each vector has a head and a tail. So according to the head and the tail theory is that if you want to solve for the resultant given two vectors that are in different directions, you have to connect the two vectors. You have to connect the head of the other vector to the tail of the other. If you have a vector like that one, this will be your tail, and that is the head. So if you have two vectors, the other one is going in a tilted direction at an angle, the other one was going horizontally, for instance. If you join the two vectors from head to tail, let me take another color. So if you connect the two, so Makazi, are you there?
Yes, sir.
Okay, so if you take the two vectors and connect them head to tail, if you take the distance from one tail, from the tail of another vector to the head of another, this will be the resultant. This will be the resultant. This will be the resultant. Now, another way, this is the head and tail method. Okay, we also introduced the parallelogram method. If you are using the parallelogram method, let me change the color, make it green. Okay, so that there's uniformity. Perfect. Okay, if you take the first vector, you can see I have tried to preserve the direction. You must always preserve the direction and the magnitude. You can move them in whatever way. You can even come and put the other vector here. You are allowed. But I'm not going to put it there. Let me put it here. And connect the two vectors like that. So if according to the parallelogram method, you need to produce a duplicate of each vector and put it parallel to each vector. So what you're gonna have is you're gonna have something like this. That is parallel, containing the same magnitude as this one. And then if you produce another one which is parallel also, you will create a parallelogram using these vectors. So using the parallelogram method, if you join the two ends, if you join this end, the tail connection and the head connection of what you have, of the vectors you have produced. If you, let me change the color. If you join the two, this will be your resultant. So it's the same thing. If you look at it, it's the same thing. So this is how you represent your resultant. If you are given two vectors that are in two dimensions, two vectors that are not in a straight line. Okay. That is about it. So next week, I am going to start with specific vectors, namely displacement, velocity, and acceleration. Displacement, velocity, and acceleration. Then from now going onwards, we're going to be doing velocity, displacement, and acceleration calculations. And we're going to do a lot of them. And that's what you're going to be meeting in your exams. We're going to do a lot of them. Okay, I will see you guys next week, Tuesday, at 5 o'clock. Next week, Tuesday, 5 o'clock. We're going to have our next lesson. I hope you have enjoyed. Cheers. And for those who are following my live, I will see you guys next week, Tuesday. Next week, Tuesday, 5 o'clock, we are starting with the lesson. Please don't forget to like and follow us. You can also follow our YouTube channel, which is Easy Teach at ARC. Easy Teach at ARC. You can follow us and also subscribe. Next week, we'll be continuing with physics. Okay, cheers. Estimated reward 12. No magical hands. You, I'm not anchorite. Anchorite. Ay. No, me anchorite.